Emulate3D can be used to model complex systems, from single pieces of machinery through to entire facilities. Whilst we gain a large amount of value from these detailed models, it can be useful to represent processes in a more abstract way. The black box component allows convenient and rapid development of models, with flexible options for experimentation and reporting. In this example, an idealized materials handling facility has been made with a mixture of real components and black boxes. Let's look at how it works. Loads arrive according to the input spreadsheet on the loads from schedule component. We can represent a trailer being unloaded by forklifts using a black box. This has a defined processing time and a fixed maximum capacity. Setting up this system is as simple as drawing a path for connections and changing the capacity and store time properties. Loads then move on to floor buffers before being moved into temporary racking. This can be represented with realistic forklifts and racking objects, or by black boxes with processing rules. All these components are compatible with each other and only require connections to be drawn between them. So far, loads have been pushed into the rack system from upstream. Now we can manage orders with flow control to pull them further through our system. We use a combination of real forklifts and black boxes representing forklifts. And the line chart shows rack utilization, telling us that we may want to increase the capacity here. Loads are pulled downstream using transport accumulation conveyor. We could lay this out realistically or use black boxes with identical behaviour. Here we use a combination of both. Black boxes excel at representing complex processes in a straightforward way. In this case, we have machinery which processes 3 pallets simultaneously, taking around 2 minutes to complete. 4 machines would run in parallel. By setting up black boxes with rules in quick logic, we can produce the same end result in a lightweight representation. This can be replaced with a more detailed model of the machinery at a later point in time. Rather than creating a full ASRS system, we can use a black box to represent the cranes and the racking. This has the advantage of being lightning fast to reconfigure. We can represent decreasing our capacity or adding in more cranes by changing single properties. We can also analyze utilization under different scenarios to optimize the system. All manner of processes can be represented with black boxes. This example pulls loads from storage and sends them to be depalletized robotically. The black box allows custom logic to be run as loads are processed in the system, such as manipulating the loads and breaking them into boxes and pallets. And this could also be extended to simulate failure rates. We can allocate loads to our own order lists, allowing us to represent rejected project or categorize loads as required. Here, we use a black box to abstractly represent a sorter for different coloured loads. As loads enter, are processed, and leave each black box, we collect data for future analysis. We can display this in tables. And if we wanted to experiment, then we're able to select parameters to vary and run automated tests with. Examples might include changing the number of forklifts or the size of each buffer. For this model, we've investigated the average amount of time loads spend on each stage of their journey. As we have time-stamped data for every load as it flows through each process, then we can extract huge amounts of useful information from each experimental configuration. The black box component is available as a downloadable catalog component, complete with detailed tutorial. Find this and many other components on the web store.